Let us now solve the second questions on motion graph kinematics. This is your question. It's a long question. We have divided it in two screens. So if you want, you can take the snapshot of the two screens, attempt the question yourself, come back and play the video. So this is the first screen of the question, and here you have the second screen of the question. So attempt the question yourself, come back and play the video again. So let us now start discussing what's happening in the question. The variation with the time t of the velocity v of a ball is shown in the figure. So what kind of a graph it is? So the first thing that you should try to understand is what kind of a graph it is. If you look at the labels, it is a velocity time graph, right? So the ball moves in a straight line from a point P at time t is equal to 0. So at time t is equal to 0, what is the point at which it is at? So you can say that this is corresponding, time t is equal to 0 corresponds to the point P, and the mass of the ball is also given to you, 400 grams. Use this figure to describe without calculation the velocity of the ball from time t is equal to 0, to time t is equal to 16. Right, so you have to describe without doing any calculation the velocity of the ball between this time period. So if you look at the graph is made up of two straight lines, one straight line which goes up, another straight line which is going down. One straight line is a straight line of a positive gradient. Another straight line that you see is a straight line of negative gradient. Positive gradient means there is a constant acceleration. Negative gradient means there is a constant deceleration. Constant deceleration and constant acceleration. Why? Because they are straight lines. Whenever you have straight lines, it means constant. A constant rate of change of velocity. It has to be a constant acceleration or deceleration depending on if the slope is positive, it is a constant acceleration. If the slope is negative, it is a constant deceleration. So you have identified the type of the two straight lines. You can now write your answer. Let us complete the numbers. You also need to complete the numbers here. So 2, 4, 6, 8. So what is happening? Constant acceleration is happening from time t is equal to 0 to time t is equal to 8. Constant deceleration starting from time t is equal to 8 to the final value of the time, which is 16. Right? So how do you write your answer? Here we have the answer written for you all. From 0 to 8 seconds, this is 8. It is an increasing speed at constant acceleration. It is a constant acceleration from 0 to 8. And 8 to 16, it is a decreasing speed at constant deceleration. It is a 2-mark question. You have given you 2 points, valid points. You will get 1 mark for both the points and you'll score 2 marks. 1 mark here and the next mark here. So constant is a very important term in this answer. Why? Because the picture here very clearly depicts that it is a constant acceleration. You do not see any curve, right? You see a straight line. Whenever you see a straight line, your answer should be constant, right? Constant acceleration or deceleration. It is not a curve. So let us look at the answers in the mark scheme. So this is your mark scheme for the part 1. You can read the mark scheme. I have just explained. The mark scheme also explains how you get both the 2 marks, 1 mark for each of the statement. It is a good idea that you read the mark scheme carefully to understand what kind of answers the Cambridge expects you all to write. Alright, so the first part is done. Let us move on to the second part. Use the same figure to calculate for the ball the displacement from P at t is equal to 10 seconds. So you have to calculate the displacement from p. P was what? P was time t is equal to 0. So from time t is equal to 0 to time t is equal to 10 seconds. During this period you have to calculate the displacement. So let us come to the graph now. So which is the time period they are talking about? They are talking about this time period starting from time t is equal to 0 to t is equal to 10 seconds. This is the time period that they are talking about. I'll just during this time period. T is equal to 0 to t is equal to 10. Alright, so the displacement. Let us understand what is happening to the ball during this time. What is happening to the ball? Ball is moving at an increasing speed, then it is moving with a decreasing speed, but it is not going, it is not going back, it is moving ahead only. The ball is moving ahead. If this is your ball, let us draw the ball. It is moving ahead initially with a very increasing speed, with a fast increasing speed. It is moving ahead, and then for the second part of the graph as well, this second part, I am talking about this one part and the second part which I am marking with 2 arrows. For the second part as well, it is moving ahead, but with her decreasing speed. The speed is going down, but it is still moving ahead because all the velocities are positive. If you see, all the velocity on this line, they are positive. That means the velocity is in the same direction. Though for the first part it is increasing speed. Increasing means that the speed is going up. Maybe it started from a velocity of 0. This is your ball. It started from a velocity of 0. It went up to a velocity of 5. From a velocity of 0 to the velocity of 5. And from 5 the velocity is coming down to 0 meters per second. The velocity is increasing for the green arrow from 0 to 1, 2, 3, 4, 5. And then maybe there is some friction. Right, the friction has exceeded so much that the velocity is now going down from 5 to 4 to 3 to ultimately 0. But the ball is going ahead only. Right, this is something that we need to understand. We have to find the distance moved from 0 to 10. So how do you find? Here the distance and the displacement will be the same, because the velocity is in the same direction all throughout, no matter when the velocity is increasing or the velocity is decreasing, it is in the same direction. The velocity is all positive number, positive, positive, positive. It is not going down the x-axis. Everything is positive. Velocity is in the same direction. So displacement is same as distance traveled. If you are given a velocity time graph, how do you find the distance traveled? It is the area under the graph. So all you have to do, you have to find the area under this graph. So which is the area that we are talking about? We are talking about this area. This area they are talking about. So if you can calculate the area of this triangle, this should be your answer. So what should be the area of this triangle? How much is the base? Base is 10. How much is the height? How much is the height of the triangle? Height is 5. If you see, height is 5. Half into base into height. That's the formula for the area of triangle. So this should give you 25 meters. So the answer here should be 25 meters. The displacement, as we have understood, is same as the distance in this case, because the velocity is in the same direction throughout. Initially it is accelerating then it starts to decelerate and come to rest. Alright, so first part is done. Second part, calculate the acceleration at t is equal to 10 seconds acceleration. So let us mark the point that they are talking about, t is equal to 10. So where is t is equal to 10? Let me erase all the extra bit of information from here. T is equal to 10. So at this point they are talking about the acceleration. So how do you find the acceleration when you are given a velocity time graph? You find the gradient. You see that this is a straight line. So what is the formula for finding the gradient of a straight line? You find the two coordinates of the two endpoints. So what are the coordinates of the topmost point? What are the coordinates? This was your 8. So this is your 8 and 5. What is the coordinate of the bottommost point? It is 16 and 15. Minus 15. If you see, this is all negative because you're below the x-axis. Right, so minus 15. So what is the formula for the gradient? Acceleration will be equal to the gradient. The formula for gradient is change in y over change in x. So what is the change in y? 5 minus 15. 5 minus minus 15. Please do not ignore the negative sign here. So 5 minus minus 15 over 8 minus 16. So what does it become? The numerator becomes addition, so which becomes 20 over, so in the denominator you have 8 minus 16, which is minus 8, right? So this whole thing becomes equal to minus 2.5 meters per second square. So what are you getting? You are getting an acceleration which is a negative number. Acceleration which is a negative number means deceleration, and you can see it visually with your eyes that it is a deceleration. Why? Because it is a downward going line, right? So your answer is minus 2.5 meters per second square. Let us write down the answer. And let us tally our answer with the mark scheme as well. If you see the mark scheme, they have also done the same thing. Answer is also the same. Alright, please have a proper look at the mark scheme. Every time I am showing you the mark scheme, you can pause the screen and understand the mark scheme. Alright, the maximum kinetic energy. What is the maximum kinetic energy? What is the formula for the kinetic energy? Half mv square. When will you have the maximum kinetic energy? When you have the maximum velocity. Alright, you're not going to change your mass because the ball is the same. The only thing which you can change here is your velocity. So which becomes half times, what is the mass of the ball? The mass of the ball is 400 grams or 0.4 kg. We know the mass. And what is the maximum velocity? The maximum velocity is 15 in the reverse direction, therefore minus 15, but we are not talking about the signs here because energy is not a vector quantity, right? So we'll ignore the negative sign here. We'll just take up the maximum value of the velocity, which is 15. We do not care about the direction because it doesn't matter. So 0.4 times 15 square. Let us tally with the mark scheme. You can solve it on your calculator. If you see, it's the same thing. Half mass times velocity, 45 joules. 45 joules. Alright, so this is also done. Let us come to the last part. Use your answer in B1. So they are talking about your answer in B1 and B2 to determine the time from t is equal to 0 for the ball to return to point P. So what is happening? What is happening? Let us understand. Let us take the ball as well. and let us understand what is happening here. Say that this is your ball which was moving. Alright, so how was the ball moving? So I have also brought the graph from the first page on this screen. Let us understand what is happening. Right? So initially what is happening, the ball is moving. This ball, it is moving. Let us understand in the most basic and the most detailed way possible. So initial position of the ball is at point P, which corresponds to time t is equal to 0. This is what the question said in the first part. Alright, so from 0 to 8, this is your 8, 6, 4. From 0 to 8, the velocity is increasing. 0 to 8. So from time t is equal to 0 to 8, say that this is your time t is equal to 8. The velocity has increased. The speed has increased from 0 meters per second to how much? 5 meters per second. And from 8 to 10, what is happening? From time t is equal to 8 to time t is equal to 10. Say that this is your time t is equal to 10. The speed has come down from 5 to 0 at 10. At 10th second, what is the speed? Speed is 0. Speed has come down. Speed has come down to 0 meters per second. So everything is happening in the same direction, but initially for the red arrow I am showing from 0 to 8 seconds, the speed is increasing, and from 8th second to the 10th second the speed is decreasing, but everything is in the same direction. Why? Because all the values of the velocity that you see here, they are all positive. Speed is in the same direction. After t is equal to 10 seconds, the speed is going all negative. If you see, the graph has come below the x-axis. You have now all the negative values for the velocity. For this portion of the graph, I am talking for this portion of the graph, the velocity values are all negative. Negative means that the ball has taken a turn. So the ball which was moving earlier, accelerating then decelerating, has now taken a turn and it's going back. Right? So t is equal to 10 seconds onwards, the ball has taken a turn and it is now going back. It is now going back and reaching point P at a constant acceleration. At a constant acceleration. It started at t is equal to 10 seconds. What was the velocity? The velocity was 0. The velocity when it took a turn, the velocity was 0 meters per second. So they are asking, they are asking you time for the return. Time for the return from this point to the original point P. How much time will it take? How much of a time will it take for the ball to return back to the original position when you know that the starting velocity is 0? You do not know the ending velocity, but you know one more piece of information. The another piece of information you know is that it is accelerating. It is accelerating in the reverse direction at 2.5 meters per second square. Here the acceleration in this part of the graph, you know the value of the acceleration as well. You know the initial velocity, which is 0 meters per second. You know the acceleration, which is 2.5 meters per second square. and t is the value that you need to find out, right? So you are using your answer from B, which is this answer, B second part, and B first part, which is this. And you also know the total distance traveled. What is this total distance? What is this total distance? This total distance from this point to this point is how much? It is 25 meters. You have already calculated it in the first part. You know the total displacement as well. Displacement and distance are the same thing here, 25 meters. So how do you find the value of t? Which formula makes sense? Which formula? You know the displacement, S is equal to ut. You know u as well. You do not know t, plus half at square. Displacement is 25. U is 0. Because u is 0, this first part becomes 0. So it becomes half a, which is 2.5 times t square. So you can solve this question, you can solve this whole quadratic equation, and you can find the value of t. Let us see if we are doing everything correct. Yes, we are doing everything correct. So t is equal to 4.5 seconds. This is what you will get. Your answer will be t is equal to 4.5 seconds. But is this what the question is asking about? The question is saying use your answer in B1 and B2 to determine the time from t is equal to 0 for the ball to return. So you have to find the total time taken by the ball to reach this point, end point, and come back. So this t, coming back time, you have found out already. Time taken to come back is 4.5. You have found out. And the time taken to go, and the time taken to go from this point to this point was how much? 0 to 10. 10. So you have to add these two times. Now time to go was 10, time to go was 10, and time to come back is how much? 4.5. So total time taken, your answer should be 10 plus 4.5. So the answer should be 14.5 seconds. Here is your mark scheme. 14.5 seconds. Have a look at the mark scheme, understand the mark scheme. If you have any further questions, please type in the comment box and let me know. And please do subscribe to the channel if you think that these videos are of use to you, to stay connected to the channel and to stay updated about what's coming new on the channel. It's better that you subscribe. It is also very, very helpful for the channel and for me. And second thing, please do comment in the comment box and let me know if you find the explanation good. If you want me to make any changes in the speed of the explanation, or if you want me to go into any particular details when I am talking about the explanation, please give your feedback to me in the comment section. It will be very, very helpful. Thank you so much.